Have you ever really stopped to think about what's going on under your skin? I mean, right now, just to move your hand, it's not one thing happening, it's this incredible secret system at work. And today, we're going to pull back the curtain and see how it all works. We move our bodies all day, every day, and we don't give it a second thought. But if you do stop and think, how? How do all these different pieces inside of us know how to work together to do something as simple as picking up a cup? Go ahead, do it right now. Just wiggle your fingers. Seems easy, right? But what is actually happening in there to make that possible? What's the hidden machinery that's responding to your thoughts? Yeah, you can see your skin. And if you press on your arm, you can feel the hard bones underneath. But that's just scratching the surface, literally. There's this whole hidden world between the skin and the bone that makes everything happen. And that's what we're digging into. So, how can we possibly see this hidden system in action? I mean, we can't just look inside a living person's arm. But it turns out there's a really good substitute we can use. And you might laugh, but it's a chicken wing. No, seriously. It's kind of wild how similar their structure is to our own arms. The chicken's drumette, that's basically our upper arm. The flat part, that's the elbow joint. And the tip is a lot like our forearm and hand. It makes it the perfect model for us to investigate our own bodies. And here it is. This is our key to unlocking the mystery. By taking a close look at this chicken wing, we're going to get a first-hand peek at how all the different parts, the skin, the muscle, and the bone, are all connected and how they team up to create movement. Okay, so the investigation begins. We're on the hunt for clues about how these three things, skin, muscle, and bone, work together as one single coordinated machine. So first, the skin. You notice right away it's not just a loose covering, it's stretchy and it's definitely connected to the layers underneath. Once we peel that back, we get to the muscles. And here's the big aha moment. They're physically attached to the bones. So what happens when we pull on them? Well, it's like magic. You pull on one muscle and the wing bends. Then you pull on the muscle on the opposite side and it straightens right back out. It's this beautiful, elegant pulley system. And that's it. That is the whole secret right there. The bones don't move by themselves. The muscles aren't just flexing in empty space. They are physically linked. When a muscle pulls, the bone has to go with it. Okay, so that's how the system works when it's running perfectly. It's an elegant design. But that leads to a pretty important question. What happens when it's not perfect? What happens when you introduce an injury into this finely tuned machine? So, to figure that out, the experiment gets a little more intense. This time, a researcher actually breaks one of the main bones in the wing. This creates a single point of failure in the system. And now we get to see what that one change does to everything else. So, just think for a second. What do you predict is going to happen? The muscles are still there, the skin's still there, everything else is fine. Just one broken bone. How is the wing's movement going to change? And wow, the result is dramatic. Before, the movement was controlled, it was precise. It could bend and extend right where it was supposed to. But after the injury, it's completely different. The motion is totally uncontrolled. It's just floppy. It's useless. The wing can't do its job anymore. And this is such a great illustration of how systems work. The wing isn't just a collection of parts, it's an interconnected machine. And by breaking just one of those parts, the whole system failed. It couldn't perform its main function, controlled movement. You know, what we've just seen in this little investigation perfectly demonstrates one of the most fundamental rules in all of biology, the relationship between a part's structure and its function. So when we say structure, all we mean is what something is made of and how it's put together. For example, the structure of bone is that it's hard and rigid. The structure of muscle is that it's stretchy and elastic. And function is just the specific job that a part does. A bone's function is to provide that solid framework, to give the body shape. A muscle's function is to contract and pull, creating force and making things move. And this is where it all comes together so beautifully. The bone's hard, rigid structure makes it perfect for its function of holding everything up. The muscle's stretchy, elastic structure is exactly what's needed for its function of contracting and pulling, and the skin's pliable, protective structure is perfectly designed for its job of covering it all. In every single case, the structure is perfectly suited for the job it has to do. All right, so let's zoom out and connect all the dots. What did this simple little investigation really teach us about the incredibly complex system that is our own body? Well, a few big things became really clear. First, our skin, muscles, and bones aren't just neighbors, they're parts of one big interconnected system. We also learned that the way each part is built, its structure, is what lets it do its specific job. The key to our movement is actually super simple. Muscles pull on bones. And maybe the most important takeaway, because it's a system, when just one part gets hurt, the entire system is affected and can't work the way it's supposed to.
So you really have to think about it this way. When someone breaks their arm, it's never just a broken bone. The whole system for movement in that arm is now compromised. The muscles can't do their job right, the limb can't function. An injury isn't just a broken part, it's a broken system. So we've seen how this amazing system is designed, and we've also seen just how fragile it can be. But that brings us to the most incredible part of the whole story, and the next giant mystery. If a broken part means a broken system, how in the world does that system manage to put itself back together? How does it heal?